Have you ever wondered how the earth beneath you, usually so stable, can suddenly shake and tremble? This is the intriguing phenomenon we call earthquakes, a natural process that can strike anywhere, anytime, transforming landscapes and communities in the blink of an eye. The Earth, our home, is a dynamic and constantly changing planet. Its crust, composed of large pieces called tectonic plates, are always on the move. When these plates grind against each other, they create a release of energy that travels through the Earth, causing it to shake. This is an earthquake. It's a fascinating yet terrifying testament to the power of nature, a force that can be as unpredictable as it is destructive. From the rumbling underfoot to the toppling of skyscrapers, earthquakes remind us of the immense power held within our planet's core. To comprehend earthquakes, we need to delve deep into the Earth's core. Earthquakes are not random events, but results of the Earth's dynamic processes. To understand these processes, let's delve into the world beneath our feet where tectonic plates reside. Imagine the Earth's crust as a giant jigsaw puzzle. This puzzle is made up of several large pieces known as tectonic plates. These plates aren't stationary. Driven by the heat from the Earth's core, they're constantly moving, albeit at a pace slower than a snail's crawl. Now, most of the time, these plates slide past each other smoothly. But sometimes they get stuck. The parts that get stuck are what we call fault lines, and these lines are the birthplaces of earthquakes. When the stress along these fault lines exceeds the strength of the rocks, the energy stored is suddenly released, triggering an earthquake. But how does this energy travel from the depth of the Earth to the surface? This is where seismic waves come into play. The energy released during an earthquake propagates in the form of these waves, much like ripples on a pond after you toss a pebble. There are two main types of seismic waves: body waves and surface waves. Body waves, which include P waves and S waves, are the first to be detected by seismographs. P waves, short for primary waves, move in a compressional motion, similar to the way sound travels through air. They're the fastest seismic waves and can travel through solids, liquids, and gases. On the other hand, S waves, or secondary waves, move in an up and down motion and can only travel through solids. Following the body waves, surface waves arrive. These waves move along the Earth's surface, causing most of the shaking we associate with earthquakes. They're slower than body waves, but they carry more energy and can cause the most damage. The intensity and impact of these seismic waves are what we experience as an earthquake. So the next time the ground beneath you shakes, remember, it's not just random. It's a testament to the dynamic processes deep within our Earth. The power of an earthquake is measured using a tool called the Richter scale. Now you may wonder, what exactly is the Richter scale? Developed in the early 20th century by Charles Francis Richter, this scale quantifies the energy released by an earthquake. The Richter scale is logarithmic, which means each whole number increase on the scale represents a 10-fold increase in measured amplitude and roughly 31.5 times more energy release. For instance, a 5 on the Richter scale releases 31.5 times more energy than a 4. This numerical scale helps us compare the strength of different earthquakes. So an earthquake that registers as a 6 on the Richter scale is significantly more powerful than one that registers as a 4. In essence, the Richter scale provides us with a standardized way to understand and communicate the sheer might of these natural phenomena. The Richter scale is our best tool to quantify the raw power of an earthquake. The trembling earth can have extensive impacts from the surface to human lives. When the ground shakes, the world takes notice. The effects of an earthquake can be seen in various forms, and their extent can be as diverse as our planet itself. On the Earth's surface, an earthquake can cause landslides, especially in hilly or mountainous regions. The ground, once solid, can become fluid, moving with a force that can reshape landscapes in mere moments. Entire hillsides can come down, burying valleys and blocking rivers, creating natural dams. Beyond the landslides, earthquakes can also trigger tsunamis. These towering waves are born when the seafloor shifts abruptly due to seismic activity. Rising from the ocean's depth, they can travel vast distances at high speeds, wreaking havoc upon reaching coastal areas. But the impact of earthquakes extends beyond the natural world. Human infrastructure is often at the mercy of these seismic events. Buildings may crumble, bridges can collapse, and roads might crack open. These damages not only represent a significant economic cost, but also pose a direct threat to human lives. The ripple effects of an earthquake on ecosystems are also profound. They can disrupt habitats, displace wildlife, and even alter the course of rivers, affecting both terrestrial and aquatic life. Earthquakes indeed leave a profound imprint on our world. Their impacts, whether on the surface, within ecosystems, or on human infrastructure, remind us of the immense power that lies beneath our feet. Scene script: knowing about earthquakes is the first step, but how does one prepare for such a powerful natural event? Preparedness revolves around three main pillars: plan, secure, and know. First, create an emergency plan. Discuss with your family where to meet after an earthquake, how to communicate if separated, and who to contact for help. Secondly, secure your space. Secure heavy items that could fall and cause injuries, such as bookcases, mirrors, and light fixtures. Consider installing latches on cabinets to prevent them from flying open and spilling their contents. Thirdly, know your safe spots. Within each room of your home, identify safe places to take cover, such as under sturdy furniture or against an interior wall. Stay away from glass, windows, and anything that could fall, like lighting fixtures or furniture. But remember, individual preparedness is only as good as community preparedness. Encourage your neighborhood to develop a community response plan. This could involve assigning roles, identifying resources, and planning for different scenarios. Lastly, let's not forget the importance of an emergency kit. A well-stocked kit should include water, food, first aid supplies, medicines, a flashlight, and batteries. Remember that while we can't prevent earthquakes, we can certainly prepare for them. Because when the ground beneath us starts to rumble, it's not just about surviving the quake, but also thriving in its aftermath. Preparedness can make all the difference when the earth decides to shake. Earthquakes, a testament to our planet's dynamic nature, can be both fascinating and devastating. We've journeyed through the science that drives these seismic events and the Richter scale that gives us insight into their magnitude. We've seen the far-reaching impacts on our planet's surface, ecosystems, and human infrastructure, and we've underscored the importance of preparedness, reminding us that even in the face of nature's unpredictable power, our resilience shines through. Knowledge and preparedness are our best defenses against the unpredictable power of earthquakes.